Hello everyone, welcome to this new video where we are going to go through largest permutation, which is a problem on the grading section of algorithm on HackerRank. So without wasting time, let us have a look on the problem. So in this problem, we receive as input an array of integer moving from 1 till a given number, so depending on the size of the array. So if you have an array of size 4, you are going to have element from 1 to 4. If the array is size 10, you are going to have element from 1 to 10. And then you have another input, which is k, the number of permutation you can do. In one operation, you can swap any two elements in the array. And the question here is, what is the maximum lexicography order element that you can have performing at most k swap? So that means if k is actually equal to 1, I can perform at most 1 swap, and I need to find out what is the maximum lexicography permutation that I can have. Let us take this one for instance. I have this array. If I swap the 4 and the 1, I will have 4, 3, 2, 1, which is the maximum lexicography permutation. Why? Because all the other permutation are going to be elements which are actually value less than this one. Let's take this one, which is actually one valid permutation. 2, 1, 3, 4. Just take this as a number. The number 2, 1, 3, 4 is actually less than 4, 3, 2, 1. That is why this is actually biggest. It's actually bigger than this, so it's the biggest so far. So now, given this, how are we going to solve this? How are we going to approach this problem? So my solution of solving this, I will share with you two approaches, and I will just implement one of them. The first approach is big O of n square approach, where the idea will be to loop from the first element to the last element, and then while looping, you will find the index of the biggest element, and you are going to swap that element with the first one. So at iteration 1, you are going to loop, and when looping, you are going to check, is this one the biggest? Actually, you know that if the array is size 4, the biggest is 4. Is this one 4? No. Is this one 4? No. Is this one 4? No. This is 4 actually. And then the value, the index of this one is actually index 3. So you are going to have index 3. Once you have the index 3, now you perform the permutation. The permutation will give you something like this. You are going to have 4 now here, and then you are going to have 1 here, and then here you are still going to have our 2 and our 3. At the end of this, you are sure that the biggest element has been placed exactly where it's supposed to be. You don't care about this part of the array anymore, so you just focus on this one, this sub array, and then you are going to perform the same operation until you have exploit all possible elements of k. If k is actually equal to 1, this is one permutation that you perform already, so you stop here. But if k is actually greater than 1, let's say 2, we are going to do the same for the second time, and then for the second time it will be like this. You are going to check where is actually I equal to 2, where is actually element 3. To search for element 3, I'm going to say, okay, I will have I here. I'm searching for element 3. Is the first one equal to element 3? No. This one equal to element 3. So it's I equal to 1, which is my element 3. I'm going to swipe this and this one, because I'm always swapping my biggest element with the first element, because I want my biggest element to be the nearest possible from the beginning. So this one will give me, when swapping, I will have 3 here and 2 here, and I will have 1 here. And after doing this is my sub array. I'll just rely on this, still evaluating what is the is car. And whenever I'm going to make a permutation, I'm going to decrement the value of k. If k was initially, let's say 2, right? So after doing this first permutation, k will be 1 because this is one permutation that has been performed. After this one, k will be 0. So at this stage I need to stop. But if k is still not 0, I will continue. And there's one thing interesting you need to understand here, is that despite the fact that it has been said here that the maximum value of k can be actually 10 power of 9, you do agree with me that you can never find yourself in a situation where you need to perform more than n swap, because you have only n element in the array. So you are going to perform at most n minus 1 swap. Let's say you have 2 elements in the array, you are going to perform at most 1 swap. Okay, so this was the approach of the big O of n square. And now, what makes this approach big O of n square? It is actually n square because each iteration you need to refine the position of the biggest element, which is actually making your overall complexity big O of n square. Whereas if you can create like a map, in C++ we are going to call it map. If you can create like a dictionary, that is how you're going to call it in Python, but you just say an element with key value, where the key is actually the element and the value is actually the position. That means when you are going to have an array like this, you are going to say, okay, 1 it has position 1, 2 it has position 2, 3 is at position 3, and 4 is at position 4. When having such a map, you are 100% sure that you will not need to loop again to find the index of this element and this element. No, you're just going to make permutation until the end without having to recreate or recompute the position of the biggest element. And then while doing so, the interesting thing is that you need to know exactly how to update your map. What does that mean? That means, let's say I have this array. Let's say we have this array, for instance. 1, let me take something. Let's say I have 1, 4, I have 5, I have 3, and then I have 2. Let's say I have this array, for instance. My map will be something like this. My map will tell me my map will tell me 1 is actually at position 0. I'm going 0 base, so that is why I'm doing so. 2 is actually at position 4. My map is telling me exactly what is happening. 3 is actually at position 3, which is true, and then 4 is actually at position 1, and then 5 is actually at position 2. Once you have something like this can be computed easily in big O of n to have such a map. Once you have the map, now the next thing you need to do is to now make the permutation. Let's say I want to do the first permutation. This is my array, right? The first permutation will be, the first thing I need to do is, where is the index of the biggest element? I already have this. I'm just going to search for index of element 5, which will give me 2. The first thing I need to do. And the second thing I will do is, since the biggest element is at position 2, I'm going to store or save the element which is at position 1, because I actually want to erase that element. So I'm going to save the current index. So I'm going to save this element. So I'm going to save the save 1 somewhere to keep track of it. And once I've saved the element, I can now erase the element with the biggest. So with the 5, I erase, I put 5. Once I've erased, now what I should do is that I should go where the 5 were, and then I put now the 1. I've saved the 1, so I know what element has been erased, so I can put it back here. And once I'm done with the change, what I need to do is that I need to update my map, because things has changed in my array, and then there is actually no need for me to update this element, because I will not need to deal with 5 anymore since it was the biggest. So I'm going to deal now with element from 4 till 1. But it's important for me to update the position of the element that has been saved. That means this one, because that element position has been changed, so it's no more position 0 but position 2. That was the previous element of the biggest. Once this has been done, now you can iterate through all your array while you haven't consumed all your allowed number of swap, or while you haven't reached the end of the array. So this is the big of n logic implementation of this problem. So what will it look like in the code? In code it will look like this. So I will create my map, and then so that the best name for this is not map but maybe something like indexes or anything that you prefer. So my map is just for the indexes. While looping, for each of the element I will say, okay, mp of that element we take I. Exactly what has been said here. That loop is going to create this. Once it's okay, now I'm going to say my maximum element is actually the size of the array. If I have an array of 5 elements, my maximum is 5 because I'm moving from 1 to 5. And then I'm starting at position 0. That means my first element where I need to put that maximum is actually 0. And then now while looping, I'm just going to check if at that position in the array it's not the maximum. I need to perform a swap, otherwise I just continue. What does that mean? That means for this one, for instance, at position 0 it was 1, so I had to perform a swap. But in this second case, for instance, at position 2 and position 1 is actually 4. There is no need for me to perform any swap because the goal is to have 4 here, because it's actually at this stage the biggest element. So that's why you are going to check if the array at the position is actually something which is going to increment while you are moving, because when you are starting, you are here, you want to put the biggest possible element here, and at this position the biggest possible element is actually 5. Once you have swapped, or once you have confirmed that the biggest element is here, you move to this one and you perform the same thing. You want to put the biggest element here, and at this stage of the array the biggest element is no more 5 because we are done with this. It's actually 4. After here, the biggest element at this stage is 3. You want to make sure that the biggest element is here. So actually, how do you perform the swap? You keep or you save the element that is at that position at that moment. That is what I did here. You save that element. Once you have saved the element, now you can erase the value that was there with the maximum. At this stage, you have 2 maximum elements in the array. You need to now erase the element that was placed at the maximum. That means indexes of the maximum will return you, let's say indexes of 5 will return you. Since you have this, indexes of 5 will return you 2. So you know that you have to go to mp of 0, 1, 2 to put now the save value. That means the value that you save here. That is why you came here. You say indexes or MP of the maximum, which is actually 2 for that specific case. You say array of 2 will take now the temp value that you save here. And after this, the permutation has been performed correctly. So after this, what you need to do is to decrement the number of swap, because one swap has been performed, and you need to update your map or your array of indexes. Once you are done now, you are moving one step forward. That means the maximum value is actually decreasing, because if the maximum was 5, it now moved to 4, and then the position is also incrementing. If the position was 0, now we are moving to 1, and you repeat this until you have consumed all the possible key, all the possible swap that you are allowed to use, or if you are at the end of the array. So by performing this, let us submit and see what it gives. So by performing this, you are 100% sure that you have green everywhere. So this is my approach of solving this. I hope you do enjoy it. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.